Good day, everyone. Before we start to study the main contents of our courses from chapter 1, we spend some time to talk about some foundational knowledge. These knowledge will be used throughout the course, and we call these contents in the first chapters or chapter 0. The name of this chapter is Overview. The contents that we'll talk in this chapters involves, first, why do we need to study computer architectures? I think these questions must be answered on all of the other courses that you begin to study, right? Why do we need to study that course? And in the same way, why do we need to study computer architecture? The second problem is, what is the difference between the computer architectures and computer organizations? Because in the textbook that I introduced you, we have the first one that entitled Computer Architectures and Organizations. That is the title of the textbook. But in this course, we focus on architectures only. So we need to differentiate between architectures and organizations. What is the difference between these two concepts? The third part, we will talk about the structures and functional views of computers. You know, in terms of structures and functional, the computer system is very complicated. It's a very complicated machine. And to understand the working operating principle of a complicated system, we need to use the block diagrams. And this part we'll talk about, you look at the top view that you look at the computers before we dig deep into the details at the lower levels of computers, organizations, and architectures. And the last part of these chapters, we will talk about multi-level machines, or in another ways, we talk about computer abstractions. Now, first, we talk about why do we need to study computer organizations and architectures. Normally, when I lecture these lessons in class, I will ask you to read part 003. In this part, in the textbook, the authors describe why do you need to study. But because we conduct these lectures online, so I will talk about it. And if you want to understand deeper, or if you cannot follow my lectures, you still can read part 0.3 in the textbook. The first reason is that when you study computer architectures, you will understand a computer's system functional components, the characteristic of each component, their performance, and the interactions between these components when they work together. The second reason is that when you understand the computer architectures, the interactions between components inside the computers, you can make the best use of the software tools as well as computer language when you use to create the programs. I can give you an example to explain this point. For example, if you know that your programs will run on a 64-bit system, you may choose the options of the compiler so that when you compile your programs, the object code will be optimized for a 64-bit system, right? And in the same way, if you want to run your system on a 32-bit, you will need to choose the options accordingly. Reasons that you need to study computer architectures is that there's always the relations between the basic components, that is the CPU, the memory, and the I/O systems. And let's take a look at the relationship between the CPU and the memory. There is always a dissimilarity in processing speed between those components. The CPU's processing power is always very fast, while the memory is not so fast. So, to balance the processing speed between these two components, we need to use the techniques that we will introduce later. That is the cache memory. One is very fast and the other is not so fast. So how to make the whole systems perform well? We need to use the cache memory. We will talk about this later in the next chapters. Another point is that relating to the bus organizations, there is the transmission lines between the CPU and the memory. And if you want to increase the data rate, that means the transmission speed between the CPUs and the memory, we need to increase the numbers of bits, or we can say the bus width. For example, the 16-bit bus will always be slower than the 32-bit bus, and a 32-bit system is always slower than a 64-bit system. Another point here is we talk about the number of cores of the processors. To enhance the processing speed of the computer system, normally people will increase the clock speed of the CPU or the clock speed of the whole system. And when we increase the clock speed, the CPU will run faster, but because the CPU is produced in a very small size, so when you increase the speed, the power consumptions of the processor also high, so the processor will be very hot. And nowadays, to lessen the heat dissipated from the CPU, we use another techniques. We don't increase the clocks so high, but we keep the clocks at an average level, but we increase the numbers of cores of the CPU. Through study, the scientists discovered that performance of the systems with higher core processor and low clock speed is equivalent to single core processors with very high clock speed. But what you gain is that the heat dissipations will be lessened a lot. The fourth reason that you need to study computer architectures is that sometimes you need to calculate how fast is your programs, which features of the hardware that contribute to the execution times of the program. When we study this part, we will know how to modify the parameters of the hardware, or sometimes the options of the compiler to make your program run fast on a certain hardware. The last reason is that when you have a well understanding about computer architectures, it will help you learn other subjects, other courses in curriculums, like the operating systems, like information security, and many other courses. We move to the next part. What is the difference between computer organizations and computer architectures? First, we talk about computer architectures. In a simplified statement, we can say that computer architectures is the programmable views of a computers. That is, when you are a programmer, you need to know the architectural attributes of the hardware, like the instruction set, which instructions that this CPUs own, what is the size of the instructions, the size of the operands, the size of the opcode, the number of bits that used for the data, which types of data that this CPUs support, right? And which input-output mechanisms does the CPU support, and how The instruction set address the locations of the operands, that is the architecture's attributes. And in practice, there are many different architectures exist, such as ARM or ARMs, right? This architecture is implemented on many processors like Raspberry Pis or Cortex or Exynos or Samsung's or A12s, A14s, A14X in the families of Apple's tablet, right? Or the newest Apple Silicon chips, M1, right? They use ARM architectures. For Intel's, we use x86, and in the past, the Mac computers use PowerPC architectures. About computer organizations, deals with all physical components of computer systems that interact with each other to perform various functionalities. In simplifying statements, we can say that computer organizations is the hardware aspect of a computer, and the lowest level of computer organizations is the microarchitectures. An example of the organization's attribute: the electronic circuits inside the computers, the pins of the chips that they connect together, right? The control signals and other peripheral signal, all the hardware aspect of the computers. And this is the learning objects of the students who learns in the faculties of electrical engineering. They study computer engineering. But you are programmer, so you will study the software aspect, that is architectures. Right? In the simplified views of the computer architectures, you can think that the architectures is the interconnectivities between the hardware components. Like in this slide, if some of you study with me in the introductions to information technologies, when we talk about computer structures, we talk about the block diagrams of our computers, and at that times we say that the computer's systems consist of the CPU, which is the brains of the computers. We have the memories, that is the space where the programs and the data are stored, and we have I/O system that connect the computers to the external device, right? And these components are connected together by the system bus, and we have three bus: the data bus, the green ones, right? The address bus, the orange lines here, and the control bus, that is the control signal, right? And this is kinds of the architectures. These slides show what the difference between different architectures. On the left, we have the architectures of x86, which Intel use, and on the right, we have the RAM architectures. You can see that the interconnectivities between components are quite different, right? Next, we will talk about the microarchitectures. For a single architecture, there are different hardware implementations. For example, Intel and AMD both sell microprocessors belonging to the same x86 architectures, right? And they can run the same programs. That means you can build your PC with the Intel architectures, the Intel CPU, right? You buy the motherboard, you buy the CPU, the RAM, and you insert the CPU, you plug in the RAMs, you turn your computer on, and you install the Windows operating system, right? And you can do the same way with the computers, yet you build up with the CPU from the AMD, right? Actually, the AMDs use different different microarchitectures, right? But the CPUs of the AMDs use the same architectures as the x86. That's the reason why they can run Windows, right? But the internal hardware is different because they use different microarchitectures. The trade-off is that with different microarchitectures, the AMD CPU can have a higher performance with a lower rise, and the power consumptions may be lower, right? For the same CPU of Intel, for example, they may optimize the microarchitectures for different objects. For example, for the desktop computers, they may produce kinds of processors with the H notations, right? And for the laptop computers, where the energy savings is the most important, so they need to optimize for long battery life, right? For the servers, they may need to optimize for the performance. So we have Xeons. So the Xeons or the CPUs on the desktop computers or the CPUs on the laptop computers, they use different microarchitectures.